Good evening, gentlemen, and welcome to our third technical meeting. Today we have a special company and a special sponsor. We have Gammatec and Safe Inspection. So please, we would like to thank Safe Inspection and Gammatec for their sponsorship. We really appreciate their sponsorship, and we look for a very informative presentation. I would like to ask Hashim and Nasser to comment on the sponsor. Hashim.
Yeah. Good evening, gentlemen. I would like to appreciate and extend my thanks to Safe Inspection, Omar Aburwela, and his team, also with the Gammatec. And we look forward for this interesting presentation tonight, and hopefully we can meet them face to face in the next, ASNT meeting in Bahrain, hopefully, in conference.
Thank you, Hashim. On behalf of the board and our members, we really appreciate the time that you will provide us here, and we look forward for this interesting presentation. I would like to ask Omar Aburwela to take the mic and start the introduction of Gammatec.
Good evening.
I think Omar, maybe Matthew, if you mute everybody, and Omar, can you unmute yourself?
Okay. Now
go ahead, Omar. Yes.
Okay, I would like to thank you all attendees. They participate in this meeting this evening. My name is Omar Aburwela. I'm the Safe Inspection Sales Manager. We have today a very interesting presentation and cooperate with Gammatec as a manufacturer, Ozarix as you can say the Europe and Middle East agent for this system, close proximity system. This is interested actually because there is a practical side today, let me see. John Albert, let me introduce John Albert, the sales manager for Africa and Australia. He's the presenter today, and his colleague, even the innovation manager, he will help him in the practical side. You can start, even.
Okay. Good evening, everyone. Thank you so much. My name is Jan Albert from Gammatec, sales manager for the area. We're actually going to start with my presentation currently, and then move on to the live presentations where you will meet Ivan as well. I'm going to quickly share my screen, and we can get underway. All right. Okay, welcome everyone. Thank you for joining us for our webinar on why should asset owners in production facilities consider using close proximity radiography. We are honored today to meet all here from the Saudi Arabia chapter of the ASNT, and we appreciate your time and attendance given to us today. As said, my name is Jan Albert. I'm the export sales manager for Gammatec. I've been with the company for around 9 years, and one of our developments here is the GamCPR close proximity system. We appreciate the opportunity to showcase to you the advancements that have been made and that are available in terms of radiation safety systems utilizing close proximity radiation systems. We're going to start today in 2 phases. Firstly, we are going to do the presentation on close proximity radiography. We're going to focus on the safety and the cost savings, the increased radiation safety, training and the ALARA culture, how GamCPR achieves close proximity radiography, and then of course we're going to do some live setups today in our small office here with a 55 curie source. Then just for ease of reference, when we talk about CPR as an abbreviation. I am referring to close proximity radiography as a genre in its entirety. And when we talk about the GamCPR system, that is the Gammatec specific system built that is available out there for use. For today, please let's keep everyone on mute. Well, however, we do welcome questions once we are done with the presentation, and then with the live setups, we will be reading out all the questions that you've posted in the chat box. So please feel free, and we'll then take some time at the end of this to ensure we answer all those questions as well as we can. Right, jumping into the presentation today, we are looking at close proximity radiography explained, where to use close proximity radiography and why, what are the most common CPR shot applications, and then of course, why choose the GamCPR system. Let's start off with what is close proximity radiography. It is the conducting of radiography in close proximity to authorized radiation workers, members of the public, or radiation sensitive monitoring devices in such a way as to ensure continuous operations. Close proximity radiography is achieved by utilizing a system of X-ray or gamma ray emitting devices, incorporating specific collimation with rigid or flexible shielding to reduce the primary beam and scattered radiation to safe levels at the desired barrier distance. You will see on the slide a visual comparison between conventional radiography on the left and close proximity radiography on the right. The GamCPR system was specifically developed to ensure higher productivity rates, not only for the NDT and radiography teams, but to ensure cost savings, increased productivity throughout and increased radiation safety throughout the entire worksite. We know that wherever radiography is being conducted, there are large exclusion zones where workers are not allowed to enter. With the close proximity radiography system, we are able to keep workers at their designated posts. Restrictions on movement within a site causes lost productivity, stops production, and affects planning in all departments, not only where radiography is being conducted. By utilizing close proximity radiography or CPR, you can avoid general workers not being able to get to their designated posts or conduct their daily tasks because of the access issues while radiography is being conducted on site. You will have no closed roads where piping runs nearby, no instrumentation engineers unable to do their daily checks, and no other NDT work around the same areas influence. By so doing, accelerating shutdowns and improving on productivity in general. Look, with all the above, ask yourself, how has conventional radiography on your site impacted your work programs in the past? What if you could reduce that safe working distance and the production downtime through lower radiation levels in that specific work area? How would the GamCPR system benefit you? So where should plants use close proximity radiography? We will say that almost anywhere where radiography is required. If you have a specific radiography application and it's within reach, GamCPR or close proximity is your answer. GamCPR provides massive cost and productivity benefits when utilized during shutdowns, during maintenance and turnaround on plants, in areas utilizing radiation-based technologies for process measurement, where utilizing GamCPR, you will set off no alarms, where conventional radiography will definitely set off some of those radiation-based alarms or influence readings based on these flow meters that work from radiation-based technologies. Of course, you can utilize it on new build projects to accelerate construction programs, and it is definitely available for onshore and offshore use. With such a wide use case application for GamCPR, almost no conventional radiography should be conducted where close proximity could be used. So why should asset owners specifically consider using the CPR in production facilities? We will break this down into three simple reasons and discuss them. Firstly, it's the massive cost savings, because work can continue 24/7. Secondly, it's the radiation safety, where you can achieve a true ALARA principle. As we know, ALARA is as low as reasonably achievable. So you can achieve that true ALARA principle for general workers and for radiography teams. And then lastly, for the improved image quality, because you are utilizing a selenium-75 source that provides a high-quality radiograph and works excellently in conjunction with digital radiography solutions. Okay, so let's break it down. Firstly, the massive cost savings by eliminating those non-productive costs. So you will have no shifts lost due to radiography. You will change that downtime of general workers when radiography is being conducted into productive time, being able to run radiography 24 hours a day, 7 days a week. In so doing, you will accelerate those construction programs. You can maximize your plant utilization, and you'll have a quick startup and a quicker return of the plant to the asset owner when utilizing the GamCPR system. Heading on to the second point is radiation safety. Close proximity radiography will enable you to reduce radiation levels on site for everyone. You will reduce dose rates to radiographers, ensuring the safety of the teams on site. You will reduce and eliminate dose rates to members of the public. You will reduce the chance of radiation incidents because the GamCPR system puts the radiography team in control of the barriers that they need to achieve. And they will know exactly what to expect when going to site. There's no more chance of scatter radiation or of someone unknowingly entering the radiation barrier zone. And this is a key advantage of undertaking close proximity radiography, because the radiography team will be empowered to be in control of the radiation levels that are created on site. Utilizing the GamCPR system, we get barriers down to only a few meters, 2 to 3 to 5 meters, versus conventional radiography that could have exclusion zones of up to 100 meters for high curie isotopes. You make the entire site a safer place with far less area to keep safe, and you can keep the public out while radiography is being conducted. Okay, point number 3 is improvement on that image quality. By using a radioactive source that will provide a high quality radiograph, the use of selenium-75 for industrial radiography has gained wide-ranging acceptance. The advantages of selenium-75 over iridium-192 isotope are, in short, improved contrast, better sensitivity, improved resolution. Of course, the lower energy range is much easier to shield, and you have a longer half-life for selenium-75 of up to 120 days. These covers those 3 points and the massive advantages of running a close proximity setup on site. With all the advantages listed, let's look at how we achieve and ensure safe close proximity radiography. We've got 2 points down there. Firstly, it's knowledge. It's knowledge of how radiation works and using purpose-built equipment for the job. Time, distance, and shielding are the basic laws of radiation safety. We improve on the shielding to reduce the distance and therefore the time spent exposed to higher levels of radiation. We utilize the lower energy of that selenium-75 source. In that knowledge, we use a uniquely designed selenium-75 gamma ray projector, which we'll talk about just a bit later in this presentation. And then, of course, by using that purposely designed collimation to reduce scatter radiation and kill that primary beam. We use flexible and purposely designed high-density shielding to make the system flexible as well. And we create that safety culture of ALARA. Secondly, then in the training, very important when working with close proximity radiography. It's not all about the system. It's very much to do with how well the teams can be trained to achieve ALARA and achieve close proximity radiography. So in the training that's given to customers of the GamCPR, we teach them how to achieve true close proximity radiography. We teach them how to utilize and deal with primary beam shielding. We teach them how to deal with scatter radiation. We also teach them all the calculations and methods pertaining to close proximity radiography. And then we teach them the best practices relating to the equipment use and maintenance. Now, before we jump into what the system consists of and our live part of the demo, we'll quickly discuss and ensure the system is made for purpose on site, and it can be used in a wide array of applications. And we've done this with a little animation and a couple of examples of how we do the setups. So in this slide, you will see the most common close proximity radiography shot applications. The system is flexible enough that it can be adapted to any radiography work that needs to be undertaken to get close proximity radiography on site, or to just lower down the radiation barriers on a site. The GamCPR system uses a uniquely developed system of clamp stands, shielding mats, and other accessories to allow for radiography on various pipe configurations, including the following listed here. So it's got pipe to pipe, we've got pipe to elbow, pipe to T, pipe to reducer, pipe to flange, and pipe to socket. We can break these down. So the following pipe to pipe configurations are possible when utilizing the GamCPR system. Firstly, it's the contact shot using the collimator and a shielded guide tube for when space is at a premium and you cannot set up because of various obstructions. Secondly, there's a contact shot with a projector wrap in its entirety to ensure low radiation levels. Then we've got a contact shot with a scatter cone, so killing straight into the pipe, ensuring that there's no scattered radiation, and with a fast setup time. There's the standoff shot forward ellipse, the cone up to 2 inches. Then the same standoff shot can be done forward ellipse, wrapped up to a 4-inch pipe. We can do the standoff shot superimposed straight from the top with a cone up to 2 inches. And then on the pipe to elbow configurations, you have the contact shot with the projector wrap. You can use a contact shot using the collimator and a shielded guide tube for when space is at a premium and you can't have the projector directly above the unit. There's a standoff shot backward ellipse into the bend or superimposed, wrapped up to a 4-inch pipe if possible. Then, of course, pipe configurations. You can do the same contact shot with the projector wrapped straight over the weld. You can do the contact shot using the collimator and the shielded guide tube for when space is at a premium. And then you can do the standoff shot backward ellipse or superimposed, wrapped up to a 4-inch pipe diameter. Pipe to reducer, very similar to just pipe to pipe. There you can do the same contact shot with the projector wrap, contact shot using the collimator and the shielded guide tube, or you can do the standoff shot backward ellipse up to a 4-inch pipe. Pipe to flange configurations, also definitely a possibility with the GamCPR system. You can do the contact shot using the collimator and the shielded guide tube into the flange. And you can use the standoff shot backward ellipse or superimposed, again up to a 4-inch pipe. Then the pipe to socket configurations, you can do the standoff shot superimposed, wrapped up to a 4-inch pipe. Various. That covers all the existing setups possible with a standard GamCPR kit. And we can custom make and specific applications for a customer if the requirement is there. And we will design what is needed to achieve true close proximity radiography. Anyone can get in touch with us or our distributor there in Saudi if you have a unique application or configuration not completely listed here in this menu of configurations that we have. Of course, we strive to improve on the GamCPR system and bring close proximity radiation everywhere. So the next design phase for the GamCPR system is a T-weld configuration for tank applications in not only existing builds, but in new builds where we are looking to achieve close proximity radiography in such a fashion that radiography can be conducted while tank construction and welding is underway in the same space. Something that's coming and constantly being developed. R&D. We use powerful magnets to attach the projector to one surface and then lead shielding behind it with the film on the opposite. We then use custom apertures to ensure where the radiation beam is going and make sure that it's within the shielding footprint for tank T-shots. Next up, we're also developing a profile shot configuration for corrosion and wall thickness application. It's also under development. You can watch the space for the manipulating arm and setup that we are going to do. Okay. We are quickly going to jump into why choose the GamCPR system specifically, and just quickly go through all the different features of it. Firstly, it's the circuit tungsten projector. It's a lightweight, field loadable system. It's only 8 kilograms, so easy to handle. The circuit can take up to an 80 curie selenium-75 source. Secondly, there's purpose-built collimators and apertures within the system, ensuring that we reduce the radiation beam to within the shielding footprint. We have the specifically designed clamp and stand system. So it's an articulating arm allowing for fast setup times and profile shots. Then we've got the robust shielding mats. So it's a fast shielding setup times with a wide range of pipe configurations. It's made easy by these flexible shielding mats and material that's user-friendly along with the clamps and stands. And then, of course, we supply every customer with the unique safe working distance calculator so that you can quickly calculate essential parameters for radiation safety, even before going to site. So if we look at the circuit projector, it's a tungsten projector, only 8 kilograms. It's capable of holding up to 80 curies of selenium-75. I see my presentation shows 100. That is incorrect. We can do 80 curies in this specific system. There is also a Circa 120, slightly larger, slightly heavier, that can take up to 120 curies of selenium-75 if that is a requirement by the customer. The collimator you see there at the top of all the pictures is the snap-on collimator that eliminates the flash as the source transitions between the projector and the collimator. And then this projector can, of course, it's specifically, or the GamCPR system is specifically designed around it, but it can be used for conventional radiography. No need to be limited to only CPR when that's being conducted. Shipping and transport, lightweight, compact, tungsten. If there's no source inside it, it can actually be shipped as general cargo because the shielding material is made of tungsten. If there's a source inside, then obviously it needs to be shipped under IATA regulations for radioactive material. And then, of course, we have a fleet of selenium-75 transport containers to ship to, I think we do about 69 or 70 countries across the world, and we can send a source straight to end destination where it is needed. For the GamCPR system, we've got the collimation and the shielding there, with the idea being purposely built, designed the collimators, the snap-on collimator at the top left, different apertures that Ivan will show you shortly, where you can use those to focus the radiation beam to where it is necessary. In the left here, you will see the robust and the shielding mats, flexible, loaded cassette, making for fast setup times, and of course, the radiation scatter cone, again, improving on that shot setup time every time the guys go to site. So, specifically designed clamp and stand, you'll see a quick picture there of what it looks like. Very flexible, different setups. We focus on the standoff shots for 1, 2, 3, and 4 of this back shot, which the system is then all designed for. The GamCPR calculator displayed here, you can use this and it enables the user to calculate exactly what he will need to achieve the correct barrier readings or the correct readings at the barrier. The calculator was kind of designed behind how radiation works, but also with real world setups. Real world setups into the calculator that we get robust and accurate readings as close as possible to what guys would be achieving on site, even lower. So it calculates barrier distance, which you want to calculate with a certain set barrier reading. You can calculate the dose rate at the barrier if you know what amount of mats and shielding you're going to use. And then, of course, if you have a set barrier distance and a set reading that you want to achieve, you can then calculate the layers of mats and shielding used to achieve that stuff. That is it for the live or the presentation from my side. I'm going to hand you over to Mr. Ivan Leroux. Ivan Leroux and his assistant are going to do 2 shot setups today. Firstly, it's the contact shot, and then secondly, a standoff shot as well. And we'll take some questions after that. Thank you very much. Much appreciated.
Yes, thank you, Mr. Jan Albert, and we'll go now to
Give us 2 seconds.
John. Yes.
Yes. Good evening, everyone. Thanks again for making the time to join us for this webinar on GamCPR. What we will do tonight is we will set up a contact shock on a 6-inch pipe. To save time, we've already wrapped 5 layers of shielding material around our pipe. The shielding material used is very flexible. It's bismuth impregnated silicon, and it's also got a layer of Kevlar in the middle to make it strong and durable so that it does not tear any further. This gets attached to your piping using Velcro straps and comes in various sizes as mentioned by Jan Albert. So we'll now set up a circa container onto the 6-inch pipe and expose the 55 curie source. As you've seen in the presentation, we make use of a circa CP80 collimator. The design of the collimator is concaved in the back, meaning that when it connects onto your container, there's no flash of radiation when moving from your container into your point of exposure. There's various aperture sizes that can be used. Just show you how it looks. So the aperture just pops out of place, gets dropped into the collimator and secured by tightening the front nut and locking that in place with your screw. So there's various sizes of apertures that covers a range of footprints as per requirements for different pipe sizes. So right now we've got the circa 80 collimator connected to the CP80 collimator, and we will now strap this onto the pipe using a ratchet strap. So the 5 layers of mat we've got on the bottom obviously takes care of your primary beam radiation. So what we've recently developed is what we call a scatter cone. This is still a concept that we are refining. So this is a very bare prototype, but instead of wrapping additional layers of matting around the top to reduce the scatter, all we do is we slide this over the collimator and keep it in place with an additional strap. So at this point we are ready to expose. And at roughly 3 meters, we are well below the 2.5 microsievert limit, as you can see on the screen there. As we get closer, the readings will obviously increase, but at roughly 1 meter from the source, we are below 10 microsieverts in the primary beam area. So that is the effect of the shielding mats when doing a contact shot. So what we'll do next is we'll break down the setup and we'll set up a standoff ellipse shot for a 2-inch pipe. So as you have seen in the presentation, we make use of a specifically designed clamp and stand, which has got a V block at the back, which means you always set up straight on the pipe. We make use of a chain to secure this setup to the pipe. We also provide a canvas sleeve that slides over the chain if there's a concern on a coated pipe in terms of damaging the coating. We are setting up at a 45-degree angle. For the standoff shot, we make use of a lead line shielding cassette. So you can add up to 28mm lead in increments of 4 millimeters. This should obviously work out using your calculator to ensure you've got the right amount for the activity or other parameters you would like to achieve. So once we have our cassette installed onto our cassette legs, next we will slide over our standoff legs. This is already at a fixed 17-degree angle. We've tested the ellipse opening on various SFTs, and the ellipse achieved using these is code compliant. At this point, we slide over the projector onto these legs, which allows it to be adjusted at various SFTs. And we ensure that we are perfectly aligned with the area of exposure by using a laser light that attaches to the collimator aperture directly. You'd notice it's a green laser because a green laser is more visible in sunlight compared to a red laser light. So this attaches to the collimator aperture, secured with a Velcro strap, and you would then make sure that your aperture is completely aligned with your area of exposure. In this case, we are about 15 millimeters off. So that's easily adjustable by just loosening the projector. And you would notice that we are now exactly aligned on the weld cap. And at this stage, you would now lock your collimator in place and remove your laser attachment. So we've already taken care of the primary beam radiation. What we'll do next is we will attach what we call the shielding cone. So basically, this is 2 stainless steel shells with 5 millimeters of lead cast in between. And the main purpose of this is to just reduce the scatter that comes off your pipe and your cassette. So this cone is set at an SFD of 350, but it can be made to specific requirements based on your needs. So that drops in place and gets held in place by the pipe itself and the collimator. But we know that some safety officers might have concerns with this coming off when you do a 180-degree shot. So for that, you can just use one of the Velcro straps supplied in the kit to just keep it in place during your exposure. And at this point, our setup is complete, and we will expose the 55 curie source. And again, at 3 meters, we are well below the 2.5 microsieverts. And again, as we move closer, the reading will increase. So at roughly half a meter from the actual source, we are at averaging about 3 microsieverts. Between 3 and 4 microsieverts per hour, and that's at roughly half a meter from the actual exposed source. So normally for a ellipse shot, you would have A shot and a B shot. You don't have to do the entire setup to do your next shot. All you will do is you'll loosen your ratchet and replace your film, swivel it over to your next shot, your B shot, tighten your ratchet, new film, and you are ready for your next shot. So the initial setup is slightly longer than conventional, but it's a lot quicker doing your second or third shot, depending on how many shots you want to do. And that is the long and short of the contact, standard contact, and standoff shot. And we are ready to answer any questions if you guys have. Thank you.
Yes, thank you, Jonathan, for the demonstration and very interesting, showing of this CRP, close proximity. Anybody having question?
Yeah, please, guys, any questions? We are ready. You can type them out, or if someone raises their hand, you want to ask it live, more than welcome to. While we wait, I think for some questions to come in. I know there's quite a few systems of our GammaSafe kit already in the Saudi region. Maybe 1 or 2 key differences we can discuss about some of the existing kits already working there is, of course, the cone, the scatter cone.
Nasser, I have a question.
Over here.
Yes. Yeah. Could you proceed, Abu Jassim? Let me introduce Abu Jassim Mohammed Bufar, one of our Saudi section ASNT board members. Please proceed, Abu Jassim.
Thank you, the team of Gammatec, It's really very interesting. First time I see something improvement. People, company focus on the safety. So the unique calculator for the distant calculator, can we use it for the other, for the Cobalt 60 and also for the linear accelerator and the X-ray machine, or just for radium 192?
No, so the GamCPR calculator was specifically designed for selenium-75, using those reduction factors of a selenium-75 isotope. And then what we've done and thrown in the mix there is we've done live setups like this and seen, where the radiation goes, when we collimate in a certain way, when we wrap in a certain way. And then we've introduced those live setup functions into the calculator to give you a more accurate one, but it won't work for cobalt or X-ray. The calculator itself won't. It is specifically designed around this system and selenium-75.
Oh, excellent. Because we concern safety first, especially when using radioactive materials. And myself, I work in the 30 years ago, when starting as a helper, then training, and then a trainee, then level 1 and level 2. That days, no concern for the safety. We just do something, but really we need something to improve the safety. And really I'm glad that Gammatec take the lead and improve the safety, because safety for the technician, it's really important. I like the companies to think about this, especially for the clamp and the stand when you're doing profile shot, or when you do the 2-inch for the elliptical shot. It's really, I was amazed, you go very close to the, to the 2-inch, and they are only very, the reading is very low and safe, because it's just, I was concerning about the timing, to do, because, the T&I and the project, they always, we are in a hurry to, to conduct more shot, more X-ray. In your experience, how long, it takes for, for example, for the 2-inch that you did just a minute ago?
Well, firstly, thank you for your kind words. I think safety is a very important factor, and it's exactly what the GamCPR system was designed around, is to bring safer inspections. At the end of the day, your workers and your NDT technicians are your biggest asset, and if you can make them as safe as possible, why wouldn't you do it? This is quite the simplest answer. Never mind all the people working on your end user site. In terms of setup time, if you've got a 2-person team like this, because you can use the calculator before you go to site even, you can already calculate exactly what you need. So you don't have to take, and there's various pieces of equipment to the system. I'll quickly show you on the other calculator, on the other camera. Let's just put the other camera on again. So there are various pieces. Just want to get out. There we go. There are various pieces to the system, because it needs to be so adaptable to site. Okay. Because we expect the GamCPR to be adaptable to any shot you need to do on site, there's a lot of pieces to the system. You don't want to be dragging that around. So you would use the safe working distance calculator to ensure that you take only the items that are needed for the day onto that site or for that shift. Now, a shot setup like this, the first shot setup might take you, let's say, 3 to 5 minutes to get everything in position, to get your film in place, to get your penetrometer in place, to load all your setups. But once that's done, your A, B, and your C shot happen very quickly thereafter. Moving forward to the next weld on a pipe section, you can simply loosen this up and slide this forward. So it's just that first setup, doing your test, like with normal conventional radiography, is taking that time, getting that first one perfect, takes a few minutes. After that, it's very quick, no problems.
Because, just one more comment, especially regarding, during the T&I, there is no time, and there is only limited time during, lunch or break time. So we have a limited time to do it. So it is very interesting that you can work all the time and do the inspection. No need to wait for the for the break time or the lunch time.
Okay, that's the thing. I mean, they're always in a hurry to do it in that lunchtime break, in that night shift break between 10 at night and 4 in the morning with the system. And you will see there's a very a very closed space here that we work from, you don't have that window anymore. There's no lunchtime window for you to go do radiography. You can do radiography any time of the day, any time of the night during shifts. So that eliminates that process. Not only doesn't it elongate your setup time by that much, you're going to make that up so quickly by just the amount of extra time you will have to conduct radiography on site.
Get last, and I will keep, I saw a hand from so many, but last. Do you have this equipment, all this unique calculator with your agent in Saudi Arabia? Because it's good, to conduct a trial, to convince others that this is the way, this is they can, and they can check with their current, equipment to make sure it's safe and it can be used, and it can increase the number of, of the shot, or increase the number of the joint that going to be, to be inspected. So, we believe, we see you. We see, but it's good, to see with, in life, we can see it, we verify, we do a trial, and I'm sure it will help. It will help you as a, as a manufacturer, and help also the service provider to implement, those equipment, especially, and I'm really interested with the unique safe, calculator. It's very good, excellent. I have a question, but I will leave for other. I saw so many hands, so I'll let other talk. Otherwise, I will not stop. Thanks again for the very good, excellent.
Abu Jassim, let me interfere here. Let me answer your question. Actually, during the regulation here, the trading company like us, it's not allowed to keep something radiation. We don't have practical license to keep something like this here. But we have system here, and we have some relation with good companies here in the market. We can make some cooperation to live presentation anytime. We have the system here in many companies. We can share the contacts also.
So they have, some of the, many of the, service provider, they have a banker, or they have, or even Aramco or Sabic, they have area, for to do the test in safe area. So
system is here. System is here.
Oh, okay. Thank you. Please, Abdul Nasser, could you proceed with your question?
Good evening. Thanks for the nice presentation. I have two concepts. We have utilized, I am from SABIC. We have utilized this close proximity radiography in our plants many times. Some of the main concern what we are feeling is it is very slow, number one. And number two is that because the setting time takes a lot of.
I hear that.
Other one is that we are facing it, the cost of this particular close proximity radiography is 10 times of the normal radiography. The service vendors are charging. How you can mitigate this?
Yeah. So we've got a couple of things there. Firstly, you need to send me details of and a couple of pictures of the system that you have currently. Now, the old GammaSafe system absolutely was slower to set up. The new GamCPR system, if you got that, a lot faster. It's a lot simpler to do. The offset's already in place. The shielding cassette at the bottom is already in place. There's no need to wrap excessively. One of the key differences as well is with the standoff and the cone. There's a lot of your work can be done with the standoff shot without needing to wrap it at all. You do a basic setup like this. You slap the cone in place, and you're off when you're ready to go. If you have one of the old systems, one of the key differences as well, you'll notice that the shielding mats are what we call raw. There's no cover inside them. Now, firstly, that happened because it's got that Kevlar reinforcement, and these can't get damaged or torn anymore. Secondly, if it's within that cover that it used to be in, the setup of that is lethargic, it is cumbersome to use, and you don't get a tight enough wrap. When using it just like this, you get a tighter wrap on your system. It goes much faster. The Velcro straps are embedded within these, making for a faster setup time. So yeah, on the new system, and there is an upgrade available. If you've got a current GammaSafe kit, we can upgrade that kit at a set cost to the new GamCPR system with a few key changes and a key additional extras, and you can actually then improve on that setup time so that it's not that slow. That answers your first question. I think second question in terms of price, talk to us. Of course, you know, technologies like these cost quite a bit of money to develop, and we're talking about, you know, very, very expensive materials to work with in terms of tungsten and the bismuth impregnated mats. But there is quite a few options in terms of outright purchase, payment plans, rent to own. Like there's quite a few things. So get in touch with a distributor, your local one, and let's make a plan for you. No problem.
Thank you very much.
Thank you, Jonathan. Yes. Thank you, Abdul Nasser. Okay. Let's have.
I think there's a question from, just scroll up there a little bit.
Yeah.
That's enough. There's a question from Santosh. Santosh, you are asking, what is the minimum distance required SOD? Maybe you can just let us know what the SOD stands for. It's just not a term that we are familiar with. We might be calling it something else here in South Africa.
Yeah.
I think he means SFD.
Source to film distance.
Yeah.
Okay, source to film distance. So with the cone, you're just going to turn this upright and then we can show you. So there are two cones available, not two cones. There's two setups available, and it's all about this gap here where your pipe sits, utilizing the cone. You do anything from, you know, quarter-inch, half-inch. Although I wouldn't put it on a quarter-inch pipe; it's quite heavy. You know, but 1-inch and 2-inch pipes, you will have a 350 SFD. So from where the cone sits on your plate to where your source comes out, that's a 350 SFD source to film distance. Then you have an extension for this cone to fit larger pipes. Now you can go up to a 4-inch pipe, and that brings you up to an SFD of 450 mils. So it'll sit here with the extension at the bottom with a bigger gap to allow for a 4-inch pipe. Anything over a 4-inch pipe, you'd be going back to a contact shot anyway, depending on the code that you utilize.
Yes. Thank you, Jonathan. There are a couple of questions I have here. One from Arminga. Is any setup for tank inspection vertical joints? There is special arrangement, I believe you demonstrated during the presentation.
Yes, that's right. So that's one of the advancements of the developments we are currently busy trialing out. As soon as we feel that it's 100% and it's ready to go, we'll definitely let you know. But if you want us to maybe use you as a trial, so if you can tell us what plates are you shooting, what types of tanks are you building that you want to do radiography on, what source you are using, then let's see if we can do a mock-up here, see if you are happy with the results. It might not be true close proximity radiography, but we might be able to halve the radiation levels on your site. So that is something that is coming. We're working very hard on it, Ivan and his team. And as soon as we're ready, we'll let you guys know.
Okay, thank you. The other question, would you please tell us what is the weight of this cone you have, protection cone?
The protection cone is roughly 7 kilograms, 7 to 8 kilograms.
So it is. Great, thank you. Anybody have a question, gentlemen? Raise your hand.
Good evening. Yeah, I'm Hari. Thank you for your presentation and excellent practical demonstration. My question is regarding emergency retrieval. It's like, especially when you do radiography with this equipment, there will be chances of source track or somewhere when you are especially using. If there is any problem with the mechanical parts or whatever. So how do you have any experience, your previous experience, like any incidents, any radiation incidents, and how you responded it? And do you have any mitigation plan or any response plan for that?
We do. So you are right. There is definitely, all manufacturers do experience emergencies from time to time. So with that in mind, we've developed the collimator to allow you to insert an emergency shipping plug for the case where the sealed source cannot be locked in place. You would remove the screw on the front of the collimator and fit a emergency shipping plug. I can just show you. Emergency shipping plug with an adjustable rod would be inserted through that hole and screwed onto your collimator to avoid your source from drifting out into the exposure port, and that would allow you to then safely remove it to an area where it can be repaired or returned to the manufacturer for maintenance. The container side, that is exactly like any other container, and your standard on-site retrieval procedures would be the standard procedures which you would use.
So just a couple of key differences. If someone's not familiar with the Exertis range of projectors, we've got the 3-stage locking mechanism, which means that your coupling needs to be in place, your key needs to be in place. There's a deep crease lever at the back here. And then, of course, you'll see this projector for the front coupling part has two specifically, like Ivan said, links in here that need to connect and depress on the inside for you to unlock your source in the first place. That happens with the snap-on collimator as well as with the guide tube connector that needs to go in there and able to unlock the projector. If any of these items are not in place, the projector will not unlock. If one of these items are not in place, it will be not lock again, and you will know that there is something wrong that you need to investigate. Something very key to note is that on the SR17 pigtail and source, the selenium-75 source sits right in the middle of that pigtail, with tungsten links to the back and tungsten links to the front, forming part of its shielding material. One of the safety features on the SR17 device or the pigtail is that front link, the very front link that would go out into the guide tube or push the front of the collimator. That link activates the projector when coming back inside to lock it. If for any reason the back comes in and you've cut off the front part, there was an incident, the projector won't lock. You will immediately know there's something wrong. That front link needs to come back into the projector to activate the locking system in order to make that work. So you will immediately know and you can immediately investigate. After that, as Ivan has said, normal recovery procedures would kick into place for that.
Okay. Thank you, Mr. Jonathan and Mr. Jan. Any further question, please? Yeah, Mr. Verinder, proceed.
Yes. Yes. Good evening. My question is, now you are fixing the camera on the pipe itself. Do you have any adjustable stand to do radiography in the field? Because in the field, you may not get a proper location to fix the camera on the adjacent piping.
That's an excellent question. So for that, we use a normal collimator and guide tube. So this is the kind of the coupling that goes on the front of the projector instead of the collimator. Connected to that is a shielded guide tube. So the guide tube is shielded with the same bismuth material as the mats that you've seen. And to the front of that is a regular collimator with a source insert where your source will go into. So when you don't have space, you would have your projector away from where you are doing radiography or where there's not space, and you can have your collimator closer to where you need to conduct and do the actual shot. Is that good?
Thank you.
Yeah.
Yeah, thank you.
Yeah. Please take note, gents, that although the Circa 80, we designed the GamCPR system around the Circa 80 camera because of the selenium-75 source, the safety features and the lightweight. But you can use the Circa 80 projector completely conventionally. All the guide tubes, the connectors, the collimators between the Exertis range are all interchangeable. So it's very easy if you don't want to conduct close proximity radiography, if you don't have work for it on site, you can use it as a conventional projector, no problem.
Yes.
Yeah, one more question. Is this radiography camera is approved by CACARE in Saudi Arabia?
Yes.
Yes, it's approved, and there is a lot of cameras and complete system in the market here in Saudi Arabia.
Thank you.
Thank you, Mr. Verinder. Thank you, Mr. Jan and Mr. Jonathan. Dear Matthew, would you please proceed with the referrals? Meanwhile, we will still have some questions to be asked. Anybody have any question, please raise your hand. Okay.
So
Yes.
we can only use it with the selenium source, or we can use other sources as well?
No, the system was specifically designed for selenium-75 because it is a lower energy range isotope to shield. And for the applications of 1, 2, 3, 4-inch piping, 6 and 8-inch piping, contact shots, it normally has enough punch to get through all of those. As soon as you move over to iridium or 192 or anything else, the amount of shielding material needed to get true close proximity radiography within 2, 3, and 4 meters, the shielding material required in weight and size is just too much, and the cost is also too high.
Then there might be a limitation on the thickness.
That's correct. So in your region of interest for selenium-75, you would have a limitation in steel of 30 millimeters or so of penetration with selenium-75.
Right.
How would I use the system for a profile shot?
This one specifically is not designed yet for a profile shot, not to achieve close proximity radiography. It is also one of those advancements that we are working very hard to bring forward. For now, we are going to stick to the contact shot and the standoff shot. The profile shot would be another system that we're developing.
Okay. Mr. Ralph Davis, could you please proceed?
I think just 2 points on the development. We have developed a system for panoramic shots inside pipes. And also there is a system we're in the process of developing specifically for boilers, tubes. And the last point I've got to make is that there is a 2-day training course. I think, Umar, you were speaking earlier about safety, and that 2-day, we're a company that runs a 2-day training course, and part of that training is again a reintroduction to safety. We understand obviously safety is paramount, but that course focuses extensively on safety and setup and repeatability of setup to ensure safety. Thank you.
Yes. Thank you, gentlemen. Any more questions, please? Yes. Mr. Fathi, would you like to have a question, please?
Thank you, Basham.
Yeah.
Thank you very much, Jonathan, for this informative presentation. And on behalf of Saudi Arabian section, I would like to extend an invitation for Gammatec to participate in our Middle East NDT conference. Maybe this is a repetition of the invitation, but since Gammatec is one of the supporting and sponsoring to our Middle East NDT conference, I would like to extend this invitation and to be with us. So if you are interested, we will send you the invitation. Meanwhile, what you have presented was very nice, and we hope that we can see the benefits of this new technology in our area. Thank you very much.
Thank you very much. Thank you for the kind words. We appreciate it, and I think definitely we would love the opportunity to come to the conference. We'll work with our partners and maybe some companies there if it's at all possible for us to bring a live source in there alongside the system to show you guys the real benefits. We will definitely do so.
Well, you are most welcome, and we will do everything to make your travel and display easy and beneficial to everybody.
Thank you very much.
We look forward to hear from you. Thank you. Back to you, Hashim.
Yes. Thank you, gentlemen. Thank you, Gammatec team and Safe Inspection Mr. Omar Abarwela, for the
Hashim,
interesting
you allow me.
presentation. Yes, please. Yeah, please.
Just before we wrap up, I really thanks Safe Inspection and Gammatec for supporting, tonight. We really we have a longer very old relation with Gammatec. We need to continue the same things as Fethi or Abu Muhammad mentioned about the Middle East NDT conference, or if you have any technology or something that you would like to introduce to the industry here in Saudi Arabia, ASNT section is welcoming you at any time. And thanks again for the support and really very good, interesting presentation and interesting, especially for the safety. I really like the calculator. I will talk with Omar about, to get more information. It's really still I'm really concerned about the safety, and this is good things, and I am sure there is some improvement required. Just have a look, and it will be a unique, not only for all the industry worldwide. Thank you.
Thank you very much.
Thank you.
Thank you very much. I would like to second all my colleagues here. More than 90 attendees here enjoyed a really beneficial presentation. Everybody is asking to have a copy of this presentation. It's up to you if you want to do that, but
It's easy. It's very easy. We will give away a free copy of the presentation for every system that is bought. It's as easy as that.
Okay. hope that you sell a lot.
Yeah.
No, we'll make sure to spread it around. You guys are welcome to it.
Yeah, so really thank you very much. Thanks to all the attendees, and we look forward to see also your next technologies soon. If you want to say something, the mic is yours, Omar and Gammatec.
Nothing to say more. I would like to thank all attendees today. I already shared the contact details on the chat side. If there is any inquiries, any technical requirements, anything, we are ready for even the live presentation here. We can establish something here. Even for the training, we are thinking about making some good training for all people already have this system again, and to make the new because the old one is the old system was GamCPR, GamSafe, yes. Now it's the GamCPR, the new name, with the new tools. So we are looking for all people having this system already to take the new generation, and the people who don't have that one to try to take it now. Think about it. Thank you all.